All right, students, welcome back. I just left you off on the last video. After number 3, we measured the blue line. It's 2.1 centimeters, and we converted to decimeters using dimensional analysis. We did that together. What I asked you to do is I asked you to do this one on your own, again, using that dimensional analysis. So I'm going to take 32 millimeters, and I'm going to convert it to centimeters, okay? Before I even do that, what I'm going to do is I'm just going to rewrite my prefixes because I like to see the visual of where I am and where I'm going. So there's my base, I have my deci, centi, and then lastly milli. Okay? And what I'm going to do is I'm going to write what I'm given. So 32 millimeters. I'm going to start with making my first ladder. So let's start with our first rule. What goes up must come down. So millimeters is going to come down here. Okay? My second rule says that I'm going to convert to the base first. Okay, so base in this case is meters, right? The base of millimeters is meters. So I'm going from millimeters to base first. Okay? Our third rule says that the prefix gets the 1 every single time. So if there's 2 letters in here, prefix gets the 1. The value of milli, so again, looking at that first sheet, the value of milli would tell me that it's 0.001. And so these can cross out. Okay? But am I done yet? No, I'm not done yet. I need to get to centimeters. So I'm going to make one more. Again, I'm so sorry about these crooked lines. What goes up must come down, so meters comes down here. I'm going to put centimeters up here. The prefix gets the 1. Which one of these has a prefix? The 2 letters. Centi does, centimeters. Okay, so the 1 goes here. Then I'm going to take the value of centi and I put it to my base. So in this case, centi would be 0.01. So now all I have to do is I take my 32 on my calculator, I multiply that by 0.001, I get an answer, and then I divide by 0.01, and my answer comes out to be 3.2 centimeters. And that is how I use dimensional analysis. Now, something that you could be wondering is, well, what if I get an answer that doesn't really sit right with me? Like I'm like, I just don't feel good about it. Here's what you can do. So if I rewrite my 32 millimeters over here, I'm going to check my answer using stair step. So I know that I'm at milli right here with this M. I'm trying to get to centimeters. That's what it's asking me. Well, I know that I just have to move my decimal 1 place to the left. So if I do that and my decimal is here, if I move it 1 to the left, is that not 3.2 centimeters? Are these two the exact same thing? They sure are. So what I can do, oh my word, I don't know why I just did that. That was so terrible, but that's okay. 3.2 centimeters is equal to 3.2 centimeters. In other words, I can check my answer using the stair step. In this case, they're the same. So that tells me I did it right. My dimensional analysis checks out. I got 3.2 centimeters. It's exactly what I'm looking for, and that is how you use dimensional analysis. You should now be getting an assignment that walks you through more of these metric conversions. And if it's difficult, that's okay. It's supposed to be. This is not easy. If I got this on my first try, oh my goodness, I would be, let's just say I'd be teaching somewhere else, right? But in this particular case, we just have to work with it a little bit. We have to be patient, and with more practice, it'll come to us, okay? But always refer back to this lecture video if you need a little bit extra clarification, all right? So we're going to jump ahead, and we're going to move on to volume and mass. Don't worry, there are 0 calculations with this one, all right? So it's just listening to my audible, boring voice over and over. I'm kidding. But pay attention closely to the differences between volume and mass and how they correlate with each other. So first things first. Oh man, that's embarrassing. If I were to calculate the volume of this box, we would say that I would take length times width times height, right? For sure. So why on earth do I have 100 centimeters cubed? This should be 1,000 centimeters cubed. That's a typo. I apologize. Okay. So using this in mind, we know that we can take the volume of regularly shaped objects. In this case, this is a cube, right? I take length times width times height, and I get 1,000, not 100. 1,000 centimeters cubed, okay? But in terms of our overall definition for volume, what it is it's the amount of space an object can occupy or take up. okay? And so the SI unit for volume is the liter, but we are most commonly going to use the milliliter because that's what's easiest to measure in our labs and in our classroom, okay? So important conversion factors, 1,000 milliliters is equal to 1 liter. And 1 milliliter, this is an interesting one, is equal to 1 cubic centimeter. In other words, if I were to take 1,000 milliliters, or in this case 1 liter, I could fit 1 liter of water inside this cube. And that's what it says here. Okay, because 1 milliliter is equal to 1 centimeter cubed, the box can fit 1,000 milliliters of water or 1 liter of water. So kind of interesting. Over here on the left-hand side, it says that the volume of a solid can be measured by multiplying the lengths, and we just did that together. So we did 10 times 10 times 10. In this case, length times width times height. Okay, make sure that if I multiply my units together, right, it would be centimeters squared and then centimeters cubed because there's 3 of them, and I multiply them by themselves. Okay. If I were to be measuring the volume of a liquid, take a look. This tells me that it's in milliliters, so this tells me what my volume is. Pretty easy, right? How much space does the water occupy? Well, in this case, it would be 80, 81, 82, and maybe just shy of 83, but we'll, for the sake of the video, call it 83 milliliters. Now, how the heck do I just know that it's 83? Why wouldn't it be maybe above this line where it's close to 85? What you're looking at right here is this is a graduated cylinder. And how we measure in a graduated cylinder is we're looking at this thing called a meniscus. Now, I'm not talking about that thing in your knee. I'm talking about the meniscus of a liquid, okay? So the liquid that we measure, it could be water, it could be anything that's found inside this graduated cylinder, which is what we use to measure. But there's this thing called the meniscus, and that's that curve. And how we use it is we're going to read the bottom of that meniscus. So very at the bottom, we are so close to 83. So in this particular case, what would the volume be? I would say that that's about 83 milliliters, okay? So just read the bottom of the meniscus, and that should tell you the volume of a liquid in a graduated cylinder. All right? So here, I have a rock. Very exciting, right? All first trimester, you guys learned about rocks. I know you're in love with rocks, so I thought I'd bring them back for us. But if you look, I filled up a graduated cylinder to 150 milliliters. Now, could I take the length times the width times the height of that rock and get an accurate volume? Probably not, right? It's an irregularly shaped solid, okay? So what I'm going to do is I'm going to use the method of displacement, okay? Displacement is how I can find the volume of an irregular solid. That's the key. But if I can find the volume of a regular shaped solid, I don't have to use displacement. You could, but there wouldn't be a point to it, okay? So what I do is I fill up a graduated cylinder, and what I'm going to do is I'm going to drop the rock inside that water, and I'm going to take the difference, okay? So if we had to define what displacement is, it's the method used to find the volume of irregularly shaped objects. In this case, it's our rock. Okay, it could be a marble. It could be a lot of different things, okay? But how do we perform displacement? I kind of just explained it, but there's 3 steps. The first step is we're going to fill a graduated cylinder with any amount of water. In this case, I would want maybe something that has a 0 after at the end. So 50, 20, 30, 100, 150, great. Okay, in this case, I'm going to choose 150. All right. Second step, I drop the object in. So over on the right-hand side here, you can see the rock is at the bottom. Okay, and what I should do for my third step is subtract the final and the initial. So this is before I drop the rock in. So this is my initial. This is my final. The rock is at the bottom. If I were to take the volume, okay, so we got some multiple lines on here. Here's 200. If I went up, I bet this is 160, 170, 180, 190, 200. This moved up to 160, 170, 180, I would say that that's at. So I take 180 minus 150. The volume of this particular rock is going to be 30. Now, 30 what? Is it milliliters? I'm going to say no. it is not 30 milliliters. We're measuring water, right? We know that we're using a graduated cylinder and liquids are measured in milliliters, but because this is a solid, I'm going to say that this is 30 centimeters cubed. This tells me that we're measuring the volume of a solid. That's what I want to see, okay? So anytime that you see the volume of a solid, even though we're using displacement, I want you to use centimeters cubed, okay? Just for the sake of measuring solids. Now, moving on to mass. I think we all know how to find mass, right? I would make sure that this says 0, and then I would drop my object on there, and this will tell me how much matter is in the object. But that's the thing, is mass does not measure weight. That is completely different, okay? What we're measuring here is we're measuring the amount of matter in the object, all right? So the SI unit for mass is in kilograms, but we're going to measure in grams. And to measure mass, we're going to use a metric balance. Okay. Here's another important conversion factor. We're not going to talk about it very often. Again, here's another one. I'm not going to worry about this too much. However, star, underline, highlight this right here. In a chemical reaction, the mass of a substance before the reaction equals the mass after. So in other words, what I want you to write down, and this is super, super important, okay? Mass before equals mass after. Please, please, please write that down. That is super, super important. You need to know that. Okay, we're going to do a lab on it. We're going to do some other activities with it, but you need to know that the mass before a reaction equals the mass after a reaction. Okay, in other words, if a 5-gram ice cube melts in my iced miel, if you don't know what a miel is, it's a type of coffee, you're missing out. Super good. What will be the mass after that happens of the water? Because ice, right, we know when it melts, it becomes water. There's still 5 grams of water in there, okay? So the mass after is still going to be 5 grams, all right? Last thing here, I'm just going to talk about mass versus weight. So I'm just going to give you all the notes here first. We know that the amount of matter, that's considered mass. Mass never changes. Mass will never, ever, ever change, okay? Weight does change because weight depends upon gravity. So if you look down here at the bottom of the page, I have W equals M times G. Weight equals mass times gravity. That's what this means, okay? So how do we calculate weight? This is how you would calculate it if I ever asked you, okay? In terms of gravity, on Earth, the acceleration value for gravity is 9.8 meters per second squared. Remember, gravity, this is going to be a force that exerts some kind of a push or pull. In other words, you and I, we're constantly being pulled towards the center of the Earth at a rate of 9.6 meters per second squared. On the moon, it's 1.6 meters per second squared. So if I ask you, like, hey, where would you weigh more, on the Earth or on the moon? You would definitely say the Earth. And where is my mass the greatest? Remember, mass does not change. So if I'm 4,000 grams here, I'm going to be 4,000 grams on the moon. All right? So that is where we're going to leave off today, and I'm going to open up my next video with this question here.